So one of the methods we do, heat, smoke, rises, we go to the top of the structure and we'll cut a hole. And hopefully that will make it a lot easier, although it does introduce some more oxygen into the building. It does make it all the hot gases escape out the top, making it easier for us to get in with some water, put a fire out. Engine 97, we've laid a line from the hydrant up there. The captain will get off the engine. He'll instruct the firefighters what our goal is. They have headphones they wear inside the engines now, and we can kind of get an idea of what's going on and give assignments before they even step out of the engine. But it's always a hazardous and noisy environment in the stage. They always sound the roof. That's what he's doing up there now with that fork, is he wants to make sure where he's stepping is solid and he isn't going to fall through. They start their equipment on the ground so it's ready to go. Up the ladder they go. Firefighters are advancing the hose line. It's an 1 3/4 hose line. It flows about 200 gallons a minute. You can do the math. It's 8 pounds per gallon. We're throwing a lot of water around. They've got to do all that with the air bottles, all their turnouts on. That's what we call their yellow gear turnouts, helmets. And oftentimes, as soon as we go through the door, we can't see. It's all smoky. The smoke will come down to your waist, your knees. You know that they'll come in low and try and get a visual for what they could do. We also use thermal imaging cameras now, which have been a big help in technology as it advances, and helps us see through the smoke somewhat. Some of them are pretty darn good. They're not cheap. We're very grateful for the equipment we have. They shout their commands clear. They check the door for heat. Back of his hand. Wants to know what he's getting into. What he'll do is, before he makes entry, he'll exhaust all the air that's in the hose and check his nozzle pattern. It's a variable pattern he can do with the adjustable nozzle there to a wide pattern or a straight skin. And he'll get it where he wants it. Now they're going to mask up, turn their bottles on, put their hoods on. And if the door's able to be open, they brought some tools with them, some forcible entry tools. Meanwhile, the guys on the roof are cutting. A beautiful prop I just built. And typically, you're looking at a first stages of initial fire attack as we work. Sometimes when we have a fire somewhere, typically in a structure fire, you'll see a lot of equipment. We need to get the right number of manpower, the personnel there to affect the job we do. It takes a lot of people. It takes a coordinated effort. You've got a guy at the hydrant, a guy on the nozzle, a guy at the pump panel, a captain walking around trying to assess the scene and give proper directions to the next crew. Last year the wind blew. It wasn't nice. With the advent too of newer cars, new technology, we'll talk a little bit as they're going to do that. it's changed how we fight car fires now. We used to just walk up, squirt water, call it out. Insurance company will come pay for the car. Sorry, that's how it is. But now with the advent of a lot of new little, they put charged cylinders for all the airbags that are in the posts, the columns of the car. There's cylinders now that help prop up the hoods. They explode and have been traveled. They travel pretty far. They'll go a good 30, 40 feet. Just the cylinders alone, they'll pop out of the hoods at you. So now we have to be careful as the correct angle that we approach a vehicle, where we're squirting our water. It's a lot more technical than just walking up and throwing water on it. The newer cars now are also built with a lot of composite materials, lots and lots of plastic. We used to just call them Detroit iron. Now it's a lot of, like I said, different. It started out with plastics, and now we're into other types of products they use to build them. But it's all toxic fumes. You can't just go jamming your head in there and doing it. Little motivational speech by the captain. Don't get me wet.
Here it comes. Here it comes.
Good job, guys. That thing knocked down. And the wind blew. Sorry. Now what we're also going to do over here is Captain Khan is going to lead the truck through, and I believe we're going to pop a door off this car. And as I mentioned, with the evolution of some newer materials, they've come up with some high-strength steel. We used to, years ago, start out with, they called it Jaws of Life, First Tool. A lot of different other manufacturers have gotten involved, so we're using a brand called TNT. Same concept, spreaders, cutters. But now the newer cars are becoming more and more built out of high-strength steel. And so, henceforth, the manufacturers of the equipment we use, they've had to develop new cutters with high-strength steel cutting blades. So, it's been a challenge for us to have in the industry. Where we cut, how we cut, what we could do and what we can't do. One of the first things we like to do when we're on the scene of a vehicle that we're going to need to open up is to stabilize the vehicle. We do that by putting blocks under the car, pulling out the valve stem so the car will lower down on the block, securing the car so it doesn't go anywhere. We don't need surprises while we're in the middle of doing what we do. Now typically, I'm not going to give you a class on how to tear a car apart, but what we do is that first column right where he's going right there, we call that the A post, the very first one, and we letter them progressively on back. The one right behind him is the B column, and then the C post. If it's a station wagon, we go D, E, and F, whatever. But this is where we start. He's going to open up the gap there and look at the hinges. We used to open them up at the door lock. That was the first place we jammed the spreaders in there to try and get that lock out. But thanks to the NTBS, the people that have all the rules on how to build cars, the locks got tougher and tougher. And one of the things we found was that the hinge was weaker than the lock. So we attacked the hinges, and we found it's real quick to get a door off. Oh, that was pretty quick. And of course, before they do that, they need to really assess the vehicle. They need to find out where or if there are airbag cylinders, so that when we're cutting, we we don't get anybody hurt. Another challenge we found with vehicles, we do respond to a lot of vehicles, are hybrids and electric vehicles now. We need to know where to cut, where the high voltage is, where it's not, how to disable an electric vehicle. The manufacturers have been pretty good about coming up with some universal ways of disabling the vehicle so we don't get hurt. But nevertheless, you have a vehicle that gets plowed into by a big truck or something. All bets can be off. We can do what we can do, but we need to be knowledgeable about the systems that are inside of the latest vehicle. So right now they're popping the door off on the driver's side. The ladder truck has these tools all pre-positioned. The motor's built right there on the tray. The reels, they have hose reels that are already connected, so it's pretty quick. They get the motor started, they come out and lay their tools out. The captain will do a quick assessment of the vehicle and lay out a plan of what to do. They get to work pretty fast. During the recruits 8 weeks, they were trained in all of these aspects. The hose lays were long and many. They learned how to take hose lines up ladders, through windows, off elevated surfaces. Learned how to deal with all the truck work, all the tools that you have on the truck, and dealing with cars, getting into forcible entry into buildings. You've come a long way.
Usually just the front, and they're taking the roof off.
The truck crew right now is working on taking the roof off. We need to make access to a car to be able to get someone out safely.
Yeah, it makes it a lot easier.
Sometimes it's easier just to get things out of your way, including a door and a roof.
Back.
Sometimes
That big clamp is what
got to use your
broke the thing. Is that hard to, when it breaks the metal, to like break it off from the car? Is that hard to get through?
See, they won't break.
Good job, guys.
They just pull it back like that, and you would, like if you're on the freeway, you would tie, like you would put a rope or something so that like the truck wouldn't go by and they can flip up.
But like where they like disconnected it, so they flipped over with that big clamp thing, is that hard to do, or just the clamp thing?
It's pretty much stuff. It's got 10,000 pounds of pressure.
I didn't know if like you were like,
No, it's just heavy. It weighs, it used to weigh like 100 pounds. Now they only weigh like 50 pounds.
that's nice. I wouldn't be able to pick that thing up, so.
That's good. Thank you, Captain Costello. Thank you very much, your group, for all your help. Ladies and gentlemen, thank you very much for being here today. I invite you up. There's a snack. Give these guys a round of applause. They've earned it. I'm very, very proud of all they've learned, and look forward to long careers for all of them.
Fire.